In this video, we will discuss the problem count digit grouping of a number. So we are given with a string which consists of digits and we have to basically divide that number into some subgroup of digits. Okay, now let's see that what we have to do. So we have to make group these digits into some subgroups while maintaining their original order. So the order will be same. The task is to find number of such groupings. We don't have to output the groupings, we have to count the number of such groupings such that for every subgroup except the last one, sum of digits in a subgroup is less than or equal to sum of digits in the subgroup immediately on its right. So for example, maybe it's quite confusing. You will understand with the help of the example. Okay. What it is showing us is that we have a string of digits which is 1, 1, 1, 9. This is a string given to us. How can we divide this string? Okay. The first way. The first subgroup contains a digit 1 and the second subgroup contains 1, 1, 9. You can see that the sum of digits in this first subgroup is 1 and here it is 11. Means the sum of digits in the right subgroup is greater than which in the left subgroup. Similarly for this case, you can see here 1, 1, 19. Here also this particular condition is right, that the left subgroup has sum less than or equal to the sum of digits in the right subgroup. Similarly for other groups also you can see. But the thing is, how can we find that how many such grouping is possible? Okay, so let's take example of this only, the number which is given to us, okay, in our example, which is 1119. Okay, so let's do this. We have 1119 given to us. Okay, so let's understand the problem. How can we solve it with the help of this particular number? Okay, so there were 7 options. Okay, the first was it's like 1119. Second, it was 1119. Third, it is 11119. Okay. Fourth, it is like this. Fifth, it is like this. And sixth, maybe I'm missing something. The sixth is, obviously the seventh we can write the same number here. Okay, and for the sixth one we can write like this. Yeah, that is one. So here are 7 groupings which are possible. Okay, yeah. Now let us understand how can we find this. Okay, so there is obviously we can do it with the help of brute force approach also. In the brute force approach, you have to check for each and every possible grouping, and then we have to check the condition that if the sum of digits in the left subgroup is less than equal to in the right subgroup. But that is a brute force approach. Time complexity will be very complex. Fine. So now let's see how can we do it in less time complexity. Okay. Yeah. So let's say it. Okay. So what we are doing is, what we will do, you can see here, if I divide this particular 7 subgroups, okay, these are 7, into some categories, into some classifications. Let's see how. You can see here what is common in this one, these 3 subgroups. Something is common here. Similarly, something is common in these 2. Similarly, something is common in this one and in this one. These are 4 categories of groups which we have divided. Now let's see. This is the first category, let's say. These 3 subgroups. These 3 groups. These 3 grouping has something common in them. Can you tell? Yeah. Here you can see that this first digit is taken as a separate subgroup in these 3 grouping. If we talk about these 2 grouping, the first one is this and second one is this. The common thing here is that the first 2 digits are taken as a separate. Similarly, if we talk about the third type of grouping, which is this one, here these first 3 digits are taken as a separate. This is what we have to observe. Fine. So now let's see that, yeah, what we have to do after observing this particular thing. We have this number, okay? So now we will understand it. So first of all, we will try to always in each step. Basically, this is a task given to us. This is a problem given to us. Means we have to group the digits of the number into different subgroups. Okay, but there is a task. There is a subtask inside this particular task. That what if we have to divide a number into two subgroups only, then further into subgroups, then further into some subgroups. That is what we will do. Okay, that is what we will do. So Lord, let's understand how we will do it. Okay, what we will do, we will first only check for the number 1119. Then we will check for its first partition. Its first partition is this one. What if we divide this 1119 into a 1 and a 119? Is it possible or not? Yeah, it is possible. You can see it is possible. The sum here, I am writing the sum with red color. So here the sum of digits is 1 and here sum of digits is 11. So yeah, it is possible. Sum is less than equal to. Means yeah, it is possible. Now what we will do, we will perform that same operation for this particular string, for this particular set of digits. For here also what we will do, we will divide it into some groups. So the first division is this one from here. Can we divide it from here? Yeah, we can divide it. So it will be divided like 1 and 19. Okay. And similarly, there is one more division which is possible, which is 1, 1 and 9. If we divide it from here with this two. Now, more on. Let's divide this also. We can divide it with 1 and 9. Let's divide this also. We can divide it like 1 and 1. So this is just like a recursion. Okay. I hope that now you are getting it. First, what we have done, we have divided this 1, 1, triple 1, 9 into 1 and double 1, 9. Then we have divided this 119 into some subgroups. Then this 19 into its subgroups. This 11 into its subgroup. So from here, you can see what we are doing. We have just started from dividing it at this particular position. You can call it position number 1 at this position. And after dividing it from this position, these are the multiple subgroups which we can get. The first is 1 and 119, which is here obviously. Okay. The second is 1 and this 119. The third is this 1 and then this 119. Similarly, what we can do, we can write 1 1 1 9, which is this one and this 19, and here it is a 1. Similarly, here this both are same, like 1 1 1 9. We have already noted. These are, and you can see that they all are satisfying the condition which we have discussed. They all are satisfying. You can see here, this is what we have discussed. The same thing we have discussed. Okay. There was a mistake. Okay, the mistake was that here in this case, in this particular case, we have to write it like 111. Why? Because that particular grouping was not allowed. Okay, that was a mistake from my side. Okay, that grouping was not allowed. Means the grouping which we have written earlier was like this, but this is not allowed because this here the sum is 2, here the sum is 1, and it is greater. It cannot be. But yeah, this one is allowed. Now let's see how can we do it further. Okay, so this is what we have to do. So these 4 combinations were possible when we have divided the number from this position. After dividing it from this position, these 4 possible combinations were there. Now let's divide it from a second position, because there are another positions also, no? So let's divide it for the another position. Okay. Now let's see. Okay, let's do it. This is what we have to do. So now let's do it for the second position. So it is like we have 1 1 1 9. Okay, and now we will make partition here. First of all, we will check that yeah, this partition is possible or not. So we have divided into 1 1 and a 1 9, and this is possible. Now we have to divide this 1 9 into its partition, which is 1 and 9. But you can see that the first partition which is allowed is this. The second partition we got it that, and here we can also divide it like this 1 and 1, but we cannot consider it because we have already considered 1 1 1 9, and we have already considered 1 1 1 9 in the above. So we will not divide it. We will just divide the second part. Okay. We'll just check for, we'll just call our function again for the second substring which is left. So we will divide it into 1 and 9, but you can see that this particular is not, this is not possible because here sum is greater. So we will not take it, we will just take this one. Similarly, we can divide it from this position also, and when we will move at the last position, we cannot divide it and we will just return. So we have to write a recursive function, okay? And what we needed, we need to store two things, because in each time we have to store two things. The first thing which we have to store is that, for example, the position from where we are going to divide, from where we are going to make partition. For example, in this case we are making partition from the second position. If we talk about the first case which we have discussed, in this case you can see that we were making partitions from the first position. Here is where we have made partition. So we need two things. The first thing is the position from where we are making partition, okay, and the second thing which we need is the sum of digits which are present previous to that position. Means previously to that disposition, this one digit is present. So you have to basically store the sum of that digits, and we will store it in a DP array or something like that. It is just like a 2D array. So we have to perform dynamic programming using recursion and also memorization, because we have to store for a particular position and previous sum. So we will understand that. Okay. So we will take a DP array. What we will do, we will take a DP array, and that DP array will be of size let's take the max size of the position, means the length of the array, and in the program it is given to us that the max size can be up to 100. You can see here max size can be up to 100. So we'll take a DP of 100. So DP will be of position and previous sum. Okay, position and previous sum means sum of previous digits left to that particular position. So this position will be at max 100 and the sum can be at max 900. Why 900? Because a maximum digit is 9. Digits are from 0 to 9 no, only. So maximum digit can be 9 and there can be maximum of 100 digits. So maximum previous sum can be 900 only. So we'll take a DP array of that to understand it. Okay. Now let's code this particular problem to understand, to implement what we have discussed. First of all, what we will do is we will initialize the DP array. Okay, and let's initialize that DP array as a public. Okay, so that we can use it in our both the functions, because we have to also create a function for recursion so that we can call it again and again. So this is a DP array. Okay, the size will be 101 and 901, because you can see here that length of string can be 100 also. That is why I've taken, to avoid any type of overflow. Okay, now what we have to do, we have to first before writing something on this total count function, first create another function which will be a recursive function for our DP algorithm or for our recursive algorithms, which will basically count. So what that function will take, the parameters, let's define the parameters for that particular function. Okay, so there will be 4 basic parameters. Okay, so that function will find count of splits for given condition. Okay, as we have discussed, we have to divide the problems into some sub problems. Okay, so this is the function. So here first it is the position from where we have to split, as we have discussed also how we have to do, and a previous sum means the sum of digits previous to that position. Int length means the length of the string given to us, and string num is the string given to us, which is here str in this case. This is the function. Okay, so we will use this function for recursive calls. Fine. Now what we will do, we have to call this function also. So let's call it. Okay, then we will implement that function. So we will call that function. So here also we have to initialize the DP state. So let's first find the length of our string, which let's say L. So that will be our length. Fine. Now if we talk about the DP state, so we can set all the numbers to -1, means sorry, yeah, we will set it to -1, the whole length of this DP. Okay, we can write like the usual syntax, size of DP, right? Yeah, so here we have initialize our DP state. Now we can call the function. So to call the function, what we have to do, we have to pass the parameters given to us. So the first will be, let's call the function count groups. The first will be just 0, because the position we will start will be 0 only. We will start always from a 0 position. Okay, now the previous sum, because the position is 0, means we are not splitting anything, we are just taking 1119. So it will be 0 only. There is nothing at the left of that position. The position is 0. Length is what we have counted, L, and number is str, which is given to us. So we have to store it in a variable, let's say answer, and then we have to return the answer. Now let's implement this particular function, which is a main code basic. Okay. Now first of all we have to because this is a recursive method, so we have to apply a terminating condition. Okay, so terminating condition is very important because there should be a base case. Okay, base condition. So the terminating condition will be that if position is equal to length, means obviously what we will do, let's understand it once again. So what we are doing is that we are given with a number, let's say that number only, which is 1119. Okay, so we are given with 1119. So first of all we will check for this position, then this, because we are starting from 0, this is 0, this is 1, this is 2, this is 3, this is 4, then this position, then this. When it will come at the last position, it will break. Okay, this is what means this position is the position where we have to split that string. Basically here we have to split it. Okay, that is what we have to do. Fine. This is the terminating condition which we have discussed. Now what we have to do, we have to move on. So also, because we are storing the value which we have calculated, so we have to check that is for a, because it is a recursive function, maybe that function can be called multiple time for a given value. Okay, so we have to apply a condition that if we have already calculated the value for that position and not that for that previous sum, so we don't have to calculate it once again, we have to just return that value. So if it is not equal to -1, then we have to just return it. This is what we have to do. Okay, yeah. Now the next thing which we have to discuss, yeah. So now what we have to do, obviously if it is not calculated, so we have to make it 0. If it is not calculated, we have to make it 0. So dp of position and the previous sum which is given to us, let's just copy it. It is equal to 0. So now we will make it equal to 0. Okay, fine. Now next thing. So now we have to take two variables. Okay, so the first variable can be you can say the result or the answer. Okay, so we can take two variables. So the first will be the rest variable, for example, to store the result, and second will be the sum. So this sum will store, because here in this previous sum we have sum of digits which are left to that position, means the previous to that position. Now we also need a sum to store the sum of digits after that position. Okay, so we will use a for loop to traverse from the current position to the rest of the length. Okay, so we will use a for loop which will start from the position given to us, and we will traverse up to the length of the string. You can see here we have taken a for loop. So now as we have taken two different variables to store, so what we will do, we will store the sum of these. So sum plus equal to, because it is a character, so we have to do it like stri, no, here it is num I minus 0 to take the to avoid the sky value. Okay, this is a simple phenomena. Fine. Now we have to also check the condition which is given to us. If this sum is greater than equal to the previous sum, obviously, because as it is given to us in the condition also, in the question also, that sum of digits in the subgroup is less than equal to the sum of digits in its right. So because this is sum, we are finding for the right digits for that particular position. So it should always be greater than the previous sum. If it is greater than a previous sum, then what can we do? Then we will check, we will recursively call the function for the rest of the string also. As we have discussed, first we have split that string into 119, then we have checked for that 119 also, then we have split it as 119, like that. So we have to make recursive calls. Okay, yeah. Now also in this recursive call we have to make sure some conditions. So we have to note that we have to pass current sum as previous sum, because now we are not checking for the whole string, we are checking, but now we are checking for this, from this particular position, from I plus 1. So because we are checking from this I plus 1, we don't have to give previous sum here, we have to give the updated sum, because this is the sum until this particular position. The length will be same, the number will be same. Here it is the difference. Okay. And after this particular loop, we have to just return the value of, we don't have to return, we basically have to first store it also. So basically we have to first store it, the value in the DP array, and then we have to return, it will return total number of subgroups till that till that current position. Okay. So after that, this is our whole code which we have written, which we have explained. Now let's compile it. Okay. Okay, so there is a problem. What happened? Oh, sorry. There should be a dot. No problem. Yeah, so for sample test case it is passed. Now let's submit it. Yeah, so it is submitted successfully. So now let's talk about the time complexity and the space complexity for the solution. So if we talk about the space complexity, as I told you, that we have taken a DP array, okay, and that DP array basically requires, that DP array is of size max means 100 in this case, and here we have taken 901, which is 9 into n. So if we can also make it like n. So in this case, uh, we can write that the space complexity can be O of n square, but because we have taken the max size, we can also write max of max square, because we have taken max here now. So this is what we can do. But the more important is time complexity, because in space only we have taken this DP array. You can check, or because you can also take this DP array up to the n only. But in that case, we have to make some more changes. So because that max was just 100, so we have taken DP array of till max only. Okay, to avoid any type of overrun. Now, if we talk about the time complexity, so it will also be equal to O of n square, because because what we are doing, first we have divided this 111 into 1 and 119. So we are checking it for each and every positions. And how many positions are there? There are n positions. So obviously we have to count for all the n positions. And for each position also, we are recursively calling for other substrings. So it will be for each position also, we are making some O of n operations. So the total time complexity will be n into n, which will be O of n into n, or we can say O of n square. This is what given to. This is what given. Okay. So yeah, so we have understand it, and we can perform it by dynamic programming and how we can do it. Fine. So I hope this video is clear to you. If it is clear, please like the video. Please like the video. Okay. Hit the like button and also subscribe to the channel. Please comment down if this video is helpful for you, and please share it with your friends. Thank you.